It's them as again. So at any point in time, if you feel like you want to probably switch on your video, please do so with the mindset that you are being recorded. Thank you so much. I want over to Mr. Yusuf now to lead us into the story. Thank you so much. Hi, Mr. Yusuf. I made you call, so you'll be able to share your screen now.
Okay, Mr. Taiwo, thank you very much. I'll do that in a minute.
All right, sir. Thank you.
So, good afternoon, everyone. I want to believe everyone can see my screen.
Clearly, sir.
Good afternoon, everyone. Hello.
Good afternoon, sir.
Good afternoon.
Okay, so today we'll be looking at some aspects in engineering economics, and I want to believe most of it we've in either ways we've equally done one or two readings. So what I'm expected to do today is to actually buttress and solve questions if there is time on each of those aspects. So synopsis for today's class is going to be, we'll be looking at time value of money, simple and compound interest, cash flow diagram, principle of economic equivalence. We'll also be looking at evaluation of engineering project, present worth method, future worth method, annual worth method, internal rate of return. Now for this section, I don't have a comprehensive slide on that. So what I'll just do is what I'll just do is I will explain each of those concepts and how it is being related in engineering. Then next, we'll be going to cost benefit analysis in public projects. We'll also be looking at depreciation policy, cause of depreciation, and method of determining depreciation using straight line method, decline balance method, and simplified method. We'll also be looking at cost concepts, the likes of your variable cost, or fixed cost, or your total cost. And finally, we'll be looking at break-even analysis. So I want to believe these are the main aspect of the course. Regarding the project side, the banking side, I believe everyone can do the reading and clear that out. So to start with, we'll be looking at interest. So I'm not going to waste much time on interest because I personally believe that we have adequate understanding when it comes to interest calculation. So basically, we have the simple interest and the compound interest. So the simple interest formula is given as PV times R times T. What is simple interest? We are looking at an immediate interest rate. Let's take, for instance, you are considering interest at a span of 1 year, either in terms of week or in terms of month. You are considering an interest rate at a span of where 1 year maximum, then you are looking at simple interest. So when you start looking at 2 years, then you are stylishly considering compound interest. So these are the analysis of the parameters we have. Simple interest given as PV times R times T, where R is the rate and is equally expressed in percentage. PV is the present value, which we all know as our principal. T is the time, and SI is the simple interest. So to get the total amount from simple interest, it is given as PV plus SI, where PV is the present value and SI is the simple interest. Now, the present value there is also known as principal. So there is no change in the same formula you know right from secondary school. Secondary school, we all know that amount equals to P plus I, where P is the principal and I is the simple interest. So to further buttress the explanation of simple interest, I have a diagram here to analyze that better. Yeah. Which simple interest is regarded or is expressed as I equals to PRT, and the R there is expressed in percentage, which happens to be the interest rate. And to further buttress, we have this formula giving the SI amount. So we recall that we said the amount is principal or present value plus simple interest. So at this point, if I'm to relate the principal and the simple interest together, I'll be having something to be common, and that's the principal. Or is that in this course I'll be using, either I'm using principal or I'm using present value. They're actually the same. So look at this P, which is P plus PRT over 100. So something is common, which is P. So factorizing P, I have P into bracket 1 plus R times T over 100. So I hope I'm communicating. Hello, can anyone hear me?
Yes, you are, sir. We are with you.
Okay. So the next one we'll be going to is compound interest. So for compound interest, we will be looking at it in normal state and also be looking at it in a continuous state. But I want to disagree that they will set something like that in our exam. But let's still look at something on that. So for compound interest, is given as present value times 1 plus I over n all raised to power n times t. Now, I'm quite sure the one we know from secondary school is future value, which is the compound interest, equals to present value, which is the principal, into bracket 1 plus R over 100 all raised to power n. So it's the same formula, but just in a different. This is more explicit than the one we know right from secondary school. Now let me explain. Let me explain gradually. Now the FV here is called the future value, which is like the future compounding amount. While the PV is the present value, which happens to be the initial amount you're investing or the initial amount you're putting into the business, which also is regarded as your principal. And N is the compounding periods of year per year. Sorry, compounding periods per year. You also have the interest rate. Now the interest rate is normally expressed in percentage. Then you have your time in terms of years. So you guys understand it better. So for the continuous compound interest is given as FV equals to PV times E raised to power IT, where FV is still future value, PV is present value, E is the exponential, which happens to have a constant value in mathematics, 2.7183. Then I is the interest rate, which is also expressed in percentage. Then T is the time in years. So this is a diagram that further explains the compound interest based on what we know before now. So we have the CI equals to P into bracket 1 plus R over 100 plus bracket T minus 1. The same way we have simple interest to be principal times rate times time over 100. Then we have the amount of simple interest to be principal plus principal times rate times time over 100. Quite similar, we have amount to in compound interest. So which is given as principal into bracket 1 plus R over 100 plus bracket T. So in a way, the compound interest formula we used to know, perhaps right from secondary school, is basically compound interest amount. So compound interest amount. So the normal formula for compound interest is given as P into bracket 1 plus R over 100 all raised by T minus 1. Okay, so we'll go to the next one. So we need to note some of these constraints. So whenever you are dealing with compound interest at annual rate, that means your N equals to 1. At quarterly, your N equals to 4. At by compounded twice in a year, that means in a year we have 6 months, like that. So your N will be equals to 2. So if you notice the trend, whenever we are dealing with half, like quarter is 1/4 of a year. Twice in a year is like half of a year. Our N value is always whole number. But when we start dealing with few multiples like biennial, you can see that the n value equals to 1/2, which ordinarily biennial means 2 years. So if you are to express this, if you are to express an expression compounded biennial in compound interest, then you need to consider your end value as 1/2. So which means since you are dividing a fraction, since your fraction is a denominator, then it's going to result to an whole number after computation. So whenever you are compounding weekly, you have 52 weeks. Whenever you are compounding monthly, you have 12 months. So those are your constraints for n. So I think that's the only thing that is not really clear when it comes to that compound interest formula. Why other parameters there remains the same. Your t is time, your I is rate, and your PV is the present value, which happens to be your principal, and your LD is the future value, which is the amount. So the next one we'll be looking at is cash flow. See, this cash flow is one of the most important aspects when it comes to analyzing financial problems generally. So it's always good to express your financial problems on a single line on using cash flow analysis. Then you find a way to simplify based on any question you are given. So what is cash flow? Cash flows are the net amount of cash and cash equivalent being transferred into or out of a business. So basically, you are trying to relate cash received and cash spent. So for the cash received, it means inflow. For the cash spent, it means outflow. So we also look at because one of the cunning ways or one of those aspects that we might find cunning is how do we identify inflow? How do we identify outflow? Yeah, there are some basic parameters. Remember, in the accounting sector, or when it comes to balance sheet, they'll be saying something like less this, less expenses, then had this, had that. So similar application to is used in cash flow. So we'll be looking at some common terms used to represent inflow and some common terms used to represent outflow for better analysis. So types of cash flow. So the first one is first cost. There is no way you want to start something without initiating um, some amount or without having your initial cost. Now, the initial cost here is known as your investment cost. So let's take for instance, um, I want to go into a business. So the first thing is for me to put some amount of money, which I'll be expecting return at a particular rate. So automatically, I am expending, like I'm giving out. And whenever you are giving out, your cash, your significance of your cash flow will be negative whenever you are giving out. But whenever you are receiving, then the significance of your cash flow will be positive. So the first one we have is fixed cost. Now, the fixed cost is more like you are paying, you are giving out. So on your cash flow diagram, it will be negative. And whenever you are dealing with negative component on your cash flow diagram, it will be moving. So the projection of that component will go down. Negative goes down, positive goes up. So whenever you are dealing with negative component on your cash flow diagram, you'll be having the component direction to be downward. But whenever it is positive, you'll be having the component direction to be upward. So we've looked at first cost. The second one we'll be looking at is operation and maintenance. So long you are still within the same project duration, you'll be having some amount you'll be spending to maintain the whole stuff. More like you are trying to maintain the whole project. So which means you are still expending some amount of money. So that will be negative on the cash flow. The next one is salvage value. Salvage value is also called scrap value. Let's say, for instance, I've been using a system for 10 years. Then I decided to get another one, and definitely, and the other system is still working well. The most available option or that might suit the present state might be for me to sell it. So selling it, in a way, I am not losing. Though there might be drastic reduction from the initial price or the initial money I bought it and the amount I'm selling it. So let's take, for instance, I bought the component for 200,000 naira, then I'm selling it for 50,000 naira. At that point I'm selling it, I am not really losing. I am not really losing. Why? I am still gaining some amount of money. So it is called scrap value or salvage value. So you are selling it at a scrap price. So which in a way will be affected by what we call depreciation. We are still going there. So it will be affected by what we call depreciation. Okay. And so since I am not equally losing anything at that point, then my salvage value will always be positive. And that's what you are saying. So your salvage value could either be disposal cost or salvage cost. So let me explain salvage cost. Salvage cost is you giving it out and collecting money in return. That means you are selling after being used, then you collect money. For disposal cost, let's take for instance, I'm using HP Core i3, then most of the things I'm doing, the HP Core i3 can no longer um, accept it. So what will I do? I'll take the HP3 to the nearby market, add some amount of money to the HP3 in order to get a new one. So at that point, I am adding money from my own hand. So which means I am losing. So at that point, it's called disposal cost. That will be negative because I'm still giving out money. Anytime you are giving out money from your own pocket, then it means you are doing disposal disposal cost. Whenever you are collecting money, so whenever anytime you are giving out money from your own pocket, it means you'll be having a negative. But anytime you are receiving money, it means you'll be having a positive value. So the next cash flow component we'll be looking at is revenue. For the revenue, yeah, for every for every production, you are expected or will be expecting some amount of or some revenue as a return. So which means I am adding to my initial uh, initial money. The next one is overhaul. So let's take for instance, I bought a machine worth of 6 million naira, and the lifespan of the machine is 25 years. By default, I am not expected to repair the machine before that 25 years. So if by virtue of design, the machine is having fault issues by the end of the 12th year, so which means I've got to spend a lot of money to bring it back to life so I can still continue with the business. So the amount of money you are spending at that point is so called the overhaul. So it is more like the major capital expenditure that occurs during the asset life. Okay. So since I'm still spending from my pocket, it means it will have um, a negative structure on the cash flow. So let's look at cash flow diagram with example. So the example here is a machine will cost $30,000 to purchase annual operating. So a machine will cost $30,000 to purchase. So that means that is the cost price. So for me to purchase the machine, I need to pay. Okay. So from the explanation I did the other time, it means I'll be having a negative component on the cash flow diagram. So let's move on. Annual operating and maintenance cost is $2,000. Since I'll be maintaining, it means I'll still be spending from my hand. That will also be negative, will be $2,000. So the machine will save $10,000 per year in labor costs. So we save. If the machine is saving, it means I'm having a return. Then the salvage value of the machine after 5 years is 7,000. You can see I bought the machine for 30,000 naira. Now I'm selling the machine for 7,000 naira, which is more like the scrapped value because it has equally depreciation. It has equally been affected by depreciation. So you're asked to express this in a cash flow. Note the number of years we are considering is 5 years. So let's look at the analysis. Okay, good. Now the first one is a machine costs $13,000 to purchase. A machine will cost 30,000 to purchase, and that is the negative value. So you can see that I'm spending from my hand. So it means the equivalent component projection on the cash flow diagram will be downward, and that is negative. Okay, annual operating and maintenance cost will be 2,000. So which means the annual operating for the whole 5 years, annual, that means for the whole 5 years I'll be using that component, I will be operating at a cost of, or I'll be maintaining the stuff at the cost of 2,000 naira, which is also negative all through. That's why you can see the blue arrow 1, 2, 3, 4, 5. The blue arrow represents the 2,000 naira and it's still facing downward. So let's go on. The machine will save 10,000 naira per year in labor cost. Since it is saving, it means I'll be having an addition to that. So that means for the first year that the machine will start saving $10,000. Remember that same year I need to maintain the machine for $2,000. So it means the $10,000 minus the $2,000 will give us the effective cash equivalent for that year. So that if I'm going to be getting 10,000 naira as return, then I will be expending 2,000 naira as for maintenance annually. So it means at that particular point, one, the absolute cost or the absolute money I'll be having will be 8,000 naira. And by analysis, 8,000 naira is positive, which means it will be facing up. So 8,000 naira is positive, it means it will be facing up. Same application goes for second year, third year, and the fourth year. Now let's go back to fifth year. Now for that fifth year, we still have the constant inflow of 10,000 naira. We also have a constant maintenance cost.
I hope it's not my message. Many people are not even yesterday.
Hello?
Hi.
Okay, we also have a constant, yeah.
You can go ahead, sir.
Okay. So we also have a constant maintenance cost for that same year 5 for 2,000 naira. Then we have a savings from the machine, which is 10,000 naira. And at the same time, that same 5th year, I'm selling the machine at the scrap price of 7,000 naira. So let's look at our resulting output. Remember, from type of cash flow, we said salvage value will give us a positive direction because you are still getting money as long as the salvage value is salvage cost. But if it is disposal cost, that will be negative. But here it is not disposal. You are selling it to get money back. So it means you'll be having 7,000 plus 10,000 as your resulting inflow. As a resulting inflow for that year 5, then 2,000 naira as a resulting outflow for that year 5. So your cumulative or the total money you'll be left with will now be 17,000 minus 2,000, and that will obviously be $15,000. So that's the basic logic behind cash flow diagram. So what you need to do basically is study this chart, know which is negative and know which is positive, so you can always compute your cash flow diagram easily. Okay, good. In this course, there are things there are some components we need to put into consideration, which ordinarily we are expected to use a chart. The way we have Smith charts for the electrical student, the way we have or this EAT chart for the mechanical student, they will have our generally 4-figure table. The same way we have 4-figure table, we also have compound interest table. But I doubt it if the department will give us that compound interest table. However, if we are not given the compound interest table, then we are expected to find it using formula. So I'm going to display the formula so everyone can follow, and I'll explain individually. So ordinarily, we are expected to use a chart. We ought to be given a chart. But if we are not given a chart, then we will need to use the formula. Now, these are the formulas. So the first one is the first For the first line, we have f slash p comma I comma n, where f slash p simply means you want to get your future value from your present value. You want to get your future value from your present value. So what you have is future value equals to present value into bracket 1 plus I always by n. Let me write something. I'm coming. Okay. So we'll be having future value equals to present value into bracket 1 plus I all raised to power what? All raised to power n. So this is the formula for future value. So how do you now calculate f slash p comma I comma n? Is by analyzing with 1 plus I all raised to power n. So if you can get this value 1 plus I raised to power n, what you just need to do to get your future value is to multiply by your present value. So you have your future value equals to present value times 1 plus I all raised to power n, where I is your interest and n is the number of years. So let's go on. The next expression is you want to get present value from future value. That means in a question you are giving future value and you expect to get present value. So what you need to do is PV equals to
Hey, calm down.
FV into bracket 1 plus I all raised to power what? All raised to power minus what? Minus n. So this is, you are converting, in a question you are giving future value and you're expected to convert to present value. So this is the formula you are going to use. So let's go on. The three main components we'll be looking at is future value, present value, and annual value. So you can be asked to convert from one or the other, or from one to the other, or whichever way conversely. So now you are converting from future to present or present to future, from future to annual or annual to future, from annual to present or present to annual, whichever way. These are the formulas. So the next one is you are given a future value and you want to convert it to annual value. What do? You use this formula. I, that means annual value equals to future value into bracket I over in a bracket 1 plus 1 plus I, close the bracket, all raised to power n minus 1, close the bracket. So we have this. So if you are given a future value and you expect to convert the future value back to annual value, what do you need to do? You multiply your future value by this constraint, which is I over 1 plus I all raised to power n minus 1. Now, what is the essence of the chart? Let me pause here. What is the essence of the chart? For the chart, you don't need to go through all this process. So what you just need to do basically is to go to your chart, check the interest rates. So go to that exact position, go to the number of years of that interest rate, then you get the value. So go to interest and go to year, so you get the value. But since we are not giving, and if you look at all those constraints, all those formulas, the two components we have is actually the interest and the number of period. That means perhaps years, number of periods. So you don't need to stress yourself using chart. So you don't need to stress yourself whenever you are using chart. But if we are not giving the chart, you need to master all these formula in order to convert from one form to another. You have to go from annual to future, from future to the likes. So I don't know if I'm communicating. I don't know if I'm really communicating.
You
Yes,
are,
you
sir.
are.
Okay, good. Now, when we now get to the cost benefit analysis and the likes, we'll be applying some of these principles for better understanding. Okay, let's go on. Okay, we'll be looking at next one we'll be going to is cost benefit analysis. Or before this, let me stylishly explain what is regarded to as net profit value and what is regarded net present value and what is regarded to as internal rate of return. Those two are used by engineers in order to know if a particular project is viable for implementation or not. So let's take for instance, I'll be building a project this year for 2,000 naira. Then by next time, the net value or the worth of that project by that time is very low. Definitely companies will not want to go into such kind of business. So people want businesses that will give them more intake. That means interest or returns. Let me use the word return. So for net present value, from the word net, that means cumulative. So you'll be getting the cumulative of your present value at each point. So it means at every point, you might be given a future value. So what do you need to do? Using the formula I showed you guys the other time, convert your future value to present value. So convert your future value to present value, then you add all of them. So if the cumulative of your present value is greater than 0, then it means you can accept the project. But if the cumulative of your present value is less than 0, it means you should reject the problem. You should reject the project. Someone is writing on the screen. Okay. So let me come again. You might be giving future value in a question. Then you ask you might be giving future value of different states or in different states, perhaps 5 years. So what you need to do basically is to convert your future value to present value at every year. So if you are converting to present value at every year, then you do what? You find the cumulative of your present value then you check if the cumulative is greater than 0, then it means the project is viable for implementation. But if the cumulative is less than 0, it means you should not accept the project, which means you should reject the project. But when it comes to IRR, which means internal rate of return, it is also the same. The use of NPV is also the use of IRR. For IRR, we are not dealing with NPV here, but we are dealing with rates. So you'll be giving the minimum acceptable rate. Let's take, for instance, we have two entries from two different companies wanting to secure a project. So the main company with the project, we want to scrutinize each of those companies coming in for better output. So we never can tell if I will be embarking in any project. So if I'll be embarking on any project, it's expected that I have a maximum return or a maximum output. So there will be a minimum acceptable rate that if your rate is less than this, I am not going to accept. But if your rate is greater than this, then you are good to go. So what do you need to do? You need to get the rate at that point. And what is the rate? The rate is when your NPV is equal to 0. Okay, let me write. Is greater than is 0. You should accept the project. But whenever your NPV is less than 0, you should reject the problem. Okay. The next one is for IRR. IRR. Whenever your IRR is greater than the normal considerable rate, which is your minimum acceptable rate, you accept the project. But whenever your IRR is less than the minimum acceptable rate, you reject the problem. For this, you accept. For this, you reject. Okay. For this, you accept. While for this, you reject. So you'll be able to get IRR when MPV is equals to 0. Okay, when MPV equals to 0. Now, what am I saying? For MPV, it means you'll be giving your rate. So what you are just doing is you are converting all future value back to present value at that given rate. So when you find the cumulative, if the cumulative is greater than 0, you accept. If less than 0, you reject. But for IRR, you are not giving the actual rate. You're only giving the minimum acceptable rate. So for the company to accept the project, it means the rate you'll be calculating when PV is equals to 0 must be greater than the minimum acceptable rate the company is bringing forth. But if it is less, you need to reject. So, okay. Let's take, for instance, I have NPV. NPV equals to PV1 plus PV2 plus PV3. PV3. Okay, so let me go back to that chart. No, let me go back to that chart. So you guys can see what I'm saying. Okay, good. Okay. Now, if I want to convert from future to present, which formula am I going to use? I'm going to use this formula. I'm going to use this second formula. So which means I'll be using future value. I'll be using present value rather equals to future value into bracket 1 plus I all raised to the power minus n. So that means at every year, I will need to convert my future value to present. And those years, if I have present value, I don't need to convert again. Just move on. Then how do you now know present value? All those ones going down on your cash flow diagram at the present value, but all those ones going up at the future value. So you get your present value from here. So you do that for state 1, for state 2, for state 3. Then you add all of them together. You get your MPV. So if the value you are getting here is greater than 0, you accept the project. But if the value you are getting here is less than 0, you reject the project. Okay, good. But if we not want to use IRR, that means internal rate of return, it means I am not going to be giving rate. So the I here will be unknown. So what you just need to do is to find PV at every point and equate it to 0. Then you find your I, which is your rate. So if you are getting high, your I value from that calculation must be greater than the minimum acceptable rate the company is bringing forth. But if it is less, then you reject the project.
So 4%.
I hope that is clear.
Not clear.
Okay, do I need to come again?
Sir, hello, sir.
Yeah.
Yes,
hello.
please.
Sir, you were saying something about the line coming up, going up and coming down. Now, how do you recognize PV and FV?
Okay, for PV, they will always be projected downward. For FV, they will always be projected upward.
Okay, thanks.
So which means you still need to reference your cash flow diagram for you to do your PV and your FV analysis. So
I
can I move
understand.
on?
So I think you should come. I think you should come again briefly, sir. I think someone wanted you to come again.
Okay. Now, we want
Yes,
to
sir.
look at
Briefly. Thank you.
okay. We want to look at knowing if a project should be acceptable or not acceptable. So in engineering analysis, we basically have two methods. So there are many methods, but basically and majorly have two: the NPV and the IRR. The NPV is the net present value, and the IRR is the internal rate of return. So what are the conditions for you to accept? If your NPV of that project is greater than zero, that means NPV means the cumulative of your present value even if the project is to use 25 years. So you need to calculate the present value for all those 25 years and add them together to see if it is greater than zero. If it is greater than zero, you accept the project. But if it's less than zero, you reject the project. But for internal rate of return, how do you use that? Whenever the internal rate of return is greater than the minimum acceptable rate, you accept. But if it is less, you reject. So how do you now compute that to use those constraints we have here? So how do you compute that? Number one is okay. Let me break it down this way. Let me give an example. I bought a machine for 22,000 naira, which by default I'm expected to use the machine for 5 years. So it means if I want to calculate the present value, I will need to calculate the future value for year 1, year 2, year 3, year 4, year 5. So if I'm giving the future value from year 1 to year 5, then I need to convert each of those future value in each of those years back to their present value state. And that is using the formula we have here, this second line, the formula we have, this P slash F, I, N. It means I'm converting future value to present value. Okay. So I'm going to add up all those present value every year. Then I'll be getting a resulting net value, and that is the net present value. So if the net present value is greater than zero, you accept the project. But if it is less than zero, you reject the project. But when it comes to IRR, internal rate of return, you still need to get the present value at every point, but you are not considering the interest. What you make unknown for IRR is the interest. And if you look at the formula, we have PV equals to FV into bracket 1 plus I all raised power minus N, all raised power minus N. So this I we have here will be unknown if you are using IRR. The I you have here will be unknown. So for your PV1, you have FV1 into bracket 1 plus I all raised power minus 1. Your PV2 will be FV2 will be to bracket 1 plus I all raised power minus 2. Your PV3 will be equals to FV3 into bracket 1 plus I all raised power minus 3. So you do that for each year. You add all of them together and you equate it to zero because your internal rate of return will be minimum when NPV equals to zero. That means when NPV equals to zero, that is when you get at least an interest rate that is equal to the previous one. So it means at that point, the company is neither losing nor gaining. But definitely, company will not still want to go for such offer. They will still want a rate that will be higher than their own minimum rate to get a bigger output. So what are you going to do? You equate the sum to zero, knowing fully well that your interest in each of those formula is still unknown. Then you compute the analysis to make I the subject of formula and you get your resulting answer for I. So if your I is greater than the idea is still rate. So if the idea is greater than the minimum acceptable rate put forth by the company, you accept. But if the I is less than the minimum acceptable rate put forth by the company, you reject. The company should reject. That is the stance and that is the scope. Can I move on?
Yes, sir, you can, sir.
Okay. So we need to understand this chart very well. So, okay, we'll be looking at cost benefit analysis. So, cost benefit analysis is a tool that is used to determine the acceptability of a project. So, in a way, cost benefit analysis looks at the inflow and the outflow, more like the total cash flow stream. Remember when we did IRR, I said it is used to check if a project should be accepted or not. When we did MPV, same thing. Now for cost benefit analysis, it is also the same. Because basically as an engineer, you need to be very, very careful before investing in anything. Before you need to know the viability of the project, you need to know how real the project is, you need to know the rate of return, you need to know how profitable the project is before you go into anything, and that is the essence of this course. So we'll also be looking at cost benefit analysis to check if this project should be acceptable or not. So what determines the actual mode of selection? What determines if you should accept this project or not is that this must happen. But let me now classify it as two. So the first one is if you are dealing with independent output, that means individual output, then the benefit ratio with the greatest, so the benefit, the company or the outcomes with the greatest benefit ratio is what you should go for. Let me come again. If you are dealing with individual, like individual returns, which means there will be a starting cost for that individual and a benefit cost for that individual. Now, what is starting cost? What is benefit cost? Starting cost, this is the money I want to use for this project. Take this 10 million, take this 2 million, take this 3 million. Now, for that 10 million, I should have a benefit. For that 3 million, I should have a benefit. For that 2 million, I should have a benefit. So the ratio of each is what we know as cost benefit ratio. Cost benefit ratio. So if you are looking at it from individual angle, it means you need to go for the outcome with the greatest benefit ratio. Okay, but if you are looking at it from investment, that means alternative process. If I'm not using this, let me use this. Then you need to look at the one having a cost benefit ratio to be greater than or equals to 1 before you accept. But if the cost benefit ratio is less than 1, you reject. You reject. Why you go for the alternative? Don't worry. If I'm solving question, you guys understand better. But please note that to enhance the calculation process, you'll be giving minimum acceptable rate of return in percentage, because this is what you will work with to get your to establish your cost benefit ratio. So let's now go to the formula. So mathematically, cost benefit ratio can be expressed as benefits over costs. Benefits over costs. So to be comprehensive with the definition of that same formula, it is expressed as benefit over costs equals to PWB over PWC equals to EUA over EUAB over EUAC. Now, what is PWB? It is the present worth of benefit. PWC is present worth of cost. Now, EUAB is equivalent uniform annual benefit. EUAC is equivalent uniform annual cost. So these are the constraints where PWB equals to present worth benefit, PWC is present worth cost, EUAB is equivalent uniform annual benefit, EUAC is equivalent uniform annual cost. So whichever formula you are using, the main goal is that the ratio is still benefit over costs. Either you are looking at the present state or you are looking at the equivalent uniform annual. You are still dealing with what? With benefit over costs. So let's look at this example. So we have solution A. Let's take for instance a company is having a problem. So a company from solution A, solution B, solution C, they are coming. So they are proposing that they have solutions to this, and this will be the cost, and at the end of the day, this will be your benefit. So for solution A is coming up with a cost of 10,000 naira, having an equivalent benefit of 12,000 naira. Solution B is coming up with a cost of 15,000 naira, having a benefit of 90,000 naira. Solution C is coming up with a cost of 10,000 naira, having a benefit of 23,000 naira. So the first thing you need to do as an engineer, okay, good. I have about 3 proposals. So which one should I go for? I go back to cost benefit analysis. So I look at, let me see the cost ratio, or let me see the cost benefit ratio. Whichever one that is greater than 1 or equals to 1, I go for that. But if it is less than, I disapprove. Okay, so let's calculate the. Oh, sorry, before I display the answer, can anyone tell me what the cost benefit ratio of solution A will be?
1.2.
Going to be 1.2.
1.2. What of for solution B?
0.8.
0.8. What of solution C?
1.2.
Yeah? And I was so sure for solution A, you guys said 1.2, right? Which I want to assume is correct. For solution B, someone is saying is 0.8. Is that correct?
How can that be 0?
1.3.
1.8. For solution B, what will be the cost benefit ratio?
1.3. 1.3.
1.3. Okay, you might probably not need to take it to 1 decimal place. Leave it in 2 decimal places. So it's going to be what?
1.27.
So sweet. So 1.27. So the next one is solution C. What is the cost benefit ratio?
1.2.
1.2. Okay, let's see. Okay. For solution A, we have the cost benefit ratio to be 1.2. For solution B, we have the cost benefit ratio to be 1.27. And for solution C, we have the cost benefit ratio to be 1.15. So as an engineer, you're expected to go for solution B because it has the greatest cost benefit ratio. Are we together?
Yes, we're
Okay.
together.
Okay, so the feedback is solution B seems to be the best because it has the highest benefit ratio. So this solution is in line. This solution is in line with This solution is in line with the first constraint we have, and that is the first constraint we have, that outcomes with greater cost benefit ratio will be picked for individual analysis. So the second example we'll be doing is for alternatives. Okay, so the solution the engineer we need to go for is 1.27. So another example. Message. Okay, another example. So the question is, consider the table below. Which alternative should be chosen using alternative cost analysis? So you are giving MARR, that means the minimum acceptable rate of return, as 4%. Okay. Now for the initializing year, we have, sorry, for the investment year, we have it to be minus 100,000, and the second one for B, we have the minus 146,000. You see the minus there has nothing to do with the money. The minus there is just showing that you are expending it, outflow. That's the minus. So it means the money, the investment cost for A will be 100,000. The investment cost for B will be 146,000. So after year 1, the return, that means the benefit, is going to be 25,000 for A and 42,000 for B, and that goes on till the third year. So how do we now solve this question? So we are asked to, as an engineer, we are asked to pick which one is suitable. Which one is suitable? Which one should we go for? Which one is more profitable in a way? So solution. Step one is find the difference cash flow. And how do you find difference cash flow? Is by subtracting the lowest initial value to the highest initial value for each row. The lowest initial value, subtract it from the highest initial value at each row. Okay, so how do we now do that? This is the new table. So for the first row, we have the highest is 146 and the lowest is 100,000. So 146,000 minus 100,000 should give you 46,000. Like I said earlier, the negative sign you are seeing there has nothing to do with the money. It's just showing that you are giving it out. The next column, the next row rather, is 2542. So it means, and according to DCF, the difference cash flow, you need to subtract the lowest from the highest. That will be 42 minus 25. That's 17,000, and that goes on to year 3. So after getting the DCF, so let me go back. After getting the DCF, you'll be able to know your present value and your future value. Now, the present value here, is this 46,000 naira. But this present value here, this present worth here is the cost. So it means your present worth cost is 46,000 naira. Why? Because the resulting difference is from the formation of what? Of the two investment costs. 100,000 naira for A is the investment cost, and 146,000 for B is the investment cost. So your resulting difference will also be the present worth costs. So for row year 1, year 2, and year 3, you have the benefit for A from A to be 25,000 and the benefit from B to be 42,000 naira. So the difference we give annual benefit. Annual benefit. I repeat, the resulting difference is going to give annual benefit, because for year A, year 1, you have 70,000 naira as a difference. Year 2, you also have 70,000 naira as a difference. Year 3, you also have 70,000 as a difference. So it means it is annual. Annually, you'll be having 17,000 naira as the benefit. Annually, you'll be having 7,000 naira as the benefit. So let's go on. So from the table, the following parameters are visible. PWC, that's the present worth cost, is 46,000 naira, and the EUAB, equivalent uniform annual benefit, is also from. You can also get that from the table, and that is 17,000 naira. That means annually you'll be having the benefit of 7,000 naira. So what we need to do first is we convert this annual benefit to present benefit. Remember from that table, there is a row which says there is a constraint which gives converting from annual to present, and the formula is coming. Let me write it. So you can still make reference to that table. So converting from annual to present, that means PV equals to AV into bracket 1 plus I. Okay. Coming. 1 plus I, close the bracket, or is power what? Or is power n minus 1, close the bracket, then divided by, open another bracket, I, B, another bracket, 1 plus I. So 1 plus I, or is power n. So this is the formula. You want to convert your annual value back to present value. So this is the formula you are going to use. the present value equals to annual value into bracket this constraint. So it means our annual value for the benefit will now be 70,000. So I can always convert this to the present worth benefit equals to annual worth benefit times all this. So I'll be getting equivalent of present worth benefit from annual worth benefit. And note from the question, we've gotten PWC, which is the present worth cost. Okay, let's go on. Okay, so we'll be finding the present worth benefit, and that is EUAB into bracket P slash A, comma I, comma N, where the I is 4%. How is it 4%? We are given that the minimum acceptable rate of return is 4%. So it means our I is 4%. And N is 3. How is N 3? Let's go back. Number of years is 3. So this is the formula we are going to use. So that is the formula we are going to use. It's clearly written. Coming, let me erase this. Okay, it's clearly written. This is the formula. So from there you get a value. So what you just need to do is to put I as 4%, and that's 0.04, and N as 3. When you compute that on your calculator, you should have 2.7751. So you multiply that value by the annual worth, and that gives 47,176.54. So let's go on. So therefore, we can go ahead with the cost-benefit ratio. Knowing fully well that the cost-benefit ratio formula is benefit over cost equals to present worth benefit over present worth cost. And what is the present worth benefit? 47,176.54 all over the present worth cost is 46,000 naira. So if I'm to find the ratio, it is obviously greater than what? Greater than 1. So it means since I'm getting a value greater than 1, then we use the second constraint. Okay, let's go on. Conclusion: since the ratio is greater than 1, the alternative with the highest cost is acceptable. The alternative with the highest cost is acceptable. So whenever your cost-benefit ratio is greater than 1, then the alternative with the highest cost, the highest starting capital, the highest investment cost is what you should accept. How? Let me go back. Okay, for alternatives, if the cost-benefit ratio is greater than or equals to 1, then the highest cost alternative is acceptable. If the cost-benefit ratio is less than 1, then the low cost alternative is what? Is acceptable. Okay, so from our calculation, we got the value of our cost-benefit ratio to be greater than 1. So obviously, which of the input or which of the component or which of the body or company is having the highest investment cost? That's obviously B, because it's having 146,000 naira. So it means the company should go for B. Whenever your cost benefit ratio is greater than or equals to 1, then you pick the outcome with the highest investment costs.
Hello, sir.
Hello.
Sir, what if you have more than 2 companies, like maybe 4 companies? How can we apply this method to it?
Okay, sweet. Very good question. When you have multiple companies, in cost benefit analysis, it is most times restricted to 2. Why? You are relating alternatives, like you are relating body A and body B. Because you need to find the absolute difference between those bodies. And if you're having more than 1, you are no longer finding absolute difference again. I don't know if I'm communicating.
Yes, sir.
So let's say, for instance, I have A to be 100,000, B to be 140,000, C to be 150,000, D to be 692,000. Then I'm asked to find the difference cash flow. There's no way I can find absolute difference cash flow because I have more than 2 outcomes. And according to that, is highest initial value minus lowest initial value. However, in further analysis, when you have multiple, but for now, I doubt it if they will give us. For further analysis, for comprehensive understanding, when you have multiples, then you pick the highest. You do something like what we call range. So you find the highest, you find the column with the highest starting capital and the column with the lowest starting capital and find their difference. But that is not really common. That's not, but most times you'll be given two outcomes where you find their differences directly. I don't know that if that's clear.
Yes, sir. Yes, sir. It's clear. Thanks.
Okay. Okay, so our cost benefit ratio is 1.025. So it means we will be going for alternative B because it has the highest starting cost. Okay, now next one we'll be going to is depreciation. Depreciation. Okay, now what is depreciation? Depreciation is the partial reduction of the value of fixed assets used to carry out operation resulting out of limited span. Okay. If you are buying something so price today and you're selling it at so price, there will be some amount of depreciation due to different causes which we'll also be looking at, and there will be some amount of depreciation. So it is that amount of depreciation we want to look at in this course. So we look at costs of depreciation. We have wear and tear, we have perishability, we have natural usage and others. Okay, and others. So the next one is factors affecting depreciation. We have cost of assets, estimated net residual value, and estimated useful life, and many others. So there are many factors affecting the other causes of depreciation. Because of time, I'm actually restricting it to 3. So the next one we're going to is method of determining depreciation. Methods of determining depreciation. So in this class, we'll be looking at three major methods used. We're looking at the straight line method. We'll be looking at the declining balance method. We'll also be looking at the sinking fund method. Now, what is straight line? Straight line is the simplest of all. That means you want to find the total average of the total average of its usefulness. Okay. So by formula, it is expressed as the acquisition value. Let's say, for instance, I'm buying something 20,000 naira. Then at the end of 5 years, I am selling it 11,000 naira. So if I'm to find the annual unit rate of that analysis, it means it will be 20,000 naira, which is the acquisition. That's the money I used to buy, minus the scrap value or the salvage value. The scrap value or the salvage value. Minus the scratch value or the salvage value all over the number of what? The number of useful life over the number of useful life. Now, according to the initial analysis, the acquisition value is 20,000. I bought the stuff for 20,000 naira. And the scrap value or the salvage value, that means the amount I'm selling after 5 years, after the useful life, is what we call the salvage value or the scrap value. I sold it for 11,000 naira. It means the absolute difference will be 20,000 naira minus 11,000 naira, and that's 9,000 naira. So all divided by the number of useful life, and that's 5 years. So 9,000 naira divided by 5 will give me the annual unit rate of depreciation. So if I'm getting that, I can use it to get any other depreciation value at any year. Okay, let's go on. So straight line method, we have the straight line method, you have sinking fund method. So for the straight line method, like as I said, is given as acquisition value minus scrap value over number of useful life. For the sinking value is in a way is relating your present to annual and your annual. Don't worry, when I display the formula, you should be able to link it to the initial chart I showed you in terms of converting present value to future value, present value to annual value, and the likes. So the annual unit rate for sinking fund is acquisition value minus scrap value into bracket I over 1 plus I raised by n minus 1, where I is the interest rate and n is the number of useful life. So using the same question I said the other time let us use sinking fund. We already use straight line method. For sinking fund, the acquisition value is 20,000 naira. That will be 20,000 naira minus the scrap value is 11,000 naira. 20,000 naira minus 11,000 naira into bracket. Now the I, okay, for me to use sinking fund, they will give us interest rates. They'll give us interest rate. So let's say, for instance, 5% interest, that will be 0.05 divided by 1 plus 0.05 into bracket raised by n. This n now is the number of useful life, and that's 5 years minus 1. So with this, I'll be able to get annual unit rate of depreciation. So with that, I can get any other depreciation value at any point. Okay, let's go on. Then the third one is declining balance method. Declining balance method is also called diminishing method. So for the annual unit rate for declining method is 1 minus the nth root of the ratio of scrap over acquisition value over acquisition what? Acquisition value. Okay. So this method is also known as diminishing value return. So let's solve an example. An equipment costs 1 million naira and has a salvage value of 800,000 naira at the end of 10 years. So it means the initial cost price or the money, the amount I'm buying is 1 million naira, and after 10 years, I will be able to sell that equipment for 800,000 naira after buying for 1 million naira 10 years ago. So the question is, calculate the depreciated value of the equipment at the end of 7 years using A, straight line method, B, declining balance method, C, sinking fund method, or 4% compounded interest annually. Okay, so let's start with straight line method. Please note, from the question, we already know that our acquisition money or acquisition value is 1 million naira, and our salvage value, which is also known as scrap value, is 800,000 naira, where 10 years is the useful life, number of useful life. So calculate the depreciated value for the equipment at the end of 7. So we are asked to calculate the depreciated value at the end of 7 years. So firstly, using straight line method. So the parameters we can extract from the question is acquisition value to be 1 million naira, salvage value to be 800,000 naira, number of useful life to be 10 years. So calculate the depreciated value at the end of 8 years. Number 1, using straight line method. Annual rate for straight line, if you remember, if you can recall, the formula is acquisition value minus scrap or salvage value all over 10. So if you have to compute this analysis, you should be getting 20,000 naira. So that means the annual unit rate of depreciation is 20,000 naira. So after getting the annual unit of depreciation, you go back to the formula, which the formula is annual unit rate of depreciation equals to acquisition minus salvage all over number of useful life. So the number of useful life we want to consider now is 8 years, or the number of life, the lifespan we want to consider now is 8 years. It means our depreciated value will be unknown because we don't know the amount we'll be selling at the end of that 8 years. But our acquisition value will still remain the same. We cannot change that. That will still be what? 1 million naira. But our annual unit rate, we've gotten our annual unit rate using the useful lifespan. So we cannot change that too. So what you just need to do is to put the value of this acquisition value, which is 1 million naira, and you also put the value for annual unit rate, which is 20,000 naira, multiplied by that by 8. Why are you multiplying by 8? Because 8 is the number of years we are considering. Then you get your new depreciated value. So can anyone do that and tell me the answer? Hello, can anyone do that?
840,000.
840,000.
Yes,
Yep.
yes, that's
Okay.
It's correct.
So sweet. So that's the depreciated value using straight line method after 8 years. Okay, so let's go on. So we'll also be looking at declining balance method, which is also known as the diminishing method. So the annual unit rate is given by the formula 1 minus the nth root of scrapped value over acquisition value. So if you have to compute this on your calculator, you should have a 0.02206. So this is the annual unit rate using declining balance method. But the question says calculate the depreciated value at the end of 8 years. So to get the depreciated value at the end of 8 years, it means we will need to make the scrap value the subject of formula from the initial formula. And that will be acquisition value into bracket 1 minus annual unit rate all raised by n, where the n here is 8. So the acquisition value is still remains 1 million. We cannot change the annual unit rate because we got the annual unit rate using the number of useful life. So we are only asked to get the value, depreciated value at the end of 8 years. So what you need to do is substitute the value of acquisition, substitute the value for annual unit rate. So the value for acquisition should be 1 million naira. The value for annual unit rate is this, is 0.02206. So can anyone compute that and tell me the answer? Can anyone compute that and tell me the answer? Anybody?
$977,400.
127,000.
977,400.
Can you check that again? Can you check that again?
836,561.
836,561 point what?
0.13.
Okay, 0.13. Yeah, that's correct.
Yeah.
So the depreciated value using declining balance method at the end of 8 years will be 836,561.13. Very correct. So the third one we'll be looking at is sinking fund. Like I said initially, for sinking fund, you'll be giving rates. So we're giving 4% compounding interest annually. So using the formula, the annual unit rate of sinking fund is acquisition value minus scrap value or salvage value into bracket I over 1 plus I all raised by n minus 1, where I is the rate. So what you just need to do is to substitute respective values. So I'm doing this for the maximum, which is the annual unit rate. So the n I use there is the number of useful life. So if you have to compute this, you should get 16,658.188. And that happens to be the unit rate. And this happens to be the unit rate when using sinking fund. As usual, your acquisition value cannot change. Your unit rate cannot also change because your unit rate is gotten from the number of useful life. So we have to get after 5 years. So after 8 years rather. Sorry. So after 8 years, the okay, very correct. So after 8 years, the depreciated value equals to acquisition value minus annual unit rate times. Now, what am I doing? After getting the annual unit rate from the formula using the number of useful life, then for you now to get depreciated value, you go back to the formula and make scrapped value the subject of formula. Anyway you see scrap value, make it the subject of formula. So the scrap value there is the depreciated value. So for using sinking fund, still using the same rate, depreciated value will be equals to acquisition value minus annual unit rate times into bracket. Now you are now reciprocating the expression at this end. That will be 1 plus 0.04 all raised by 8 minus 1 all over 0.04. So can someone compute this and tell me the answer? Anybody? Anybody? Any value? What's the answer? Hello, can anyone hear me? I want to believe we are working on it. Okay, let me wait.
Somebody has answered in the chat.
Okay, from the chat, let me see. 846,507.69. Very correct. So that is the depreciated value using sinking fund at the end of 8 years. Then we'll move on. Okay. So the next aspect will be going, so that's all about depreciation. So we looked at definition of depreciation, we looked at causes of depreciation and factors affecting depreciation. We also looked at how to determine depreciation value using the 3 basic methods, the
Hello,
straight
sir.
line method. Hello?
Sir, please, can we get this? Can we get this slide, please?
Definitely. Yes, you can. Yeah, I'm going to send it to Mr. Taiwo at the end of this class. So I hope you guys can get it from him. So cost concept. So we looked at the analysis of how to determine depreciation value using straight line method, diminishing method, or sinking fund method at a particular interest. So the next aspect we'll be going to is cost concept. So for cost concept, we'll be looking at the 4 basic cost components we have. The first one is fixed cost. Second one is variable cost, total cost, marginal cost. So most times you see it as you see them in their acronym format or in their abbreviation format rather. And that is fixed cost is FC, variable cost is VC, total cost is TC, marginal cost is MC. So what are fixed costs? There are costs that don't change with the amount produced. So regardless of the number of stuffs you are producing, the number of quantity you're having, the amount of output you have, it is not going to change. Next one is variable cost. Costs that do change with the amount produced. It means if you are producing more and more, there's tendency for you to have a change in cost. So let's take this as case study. If I'm to produce 200 sachets of Bonfita using a single truck. So that means for me to produce 200 sachets of Bonfita, I only need a truck of cocoa. So if I'm now to double it by producing 400, it means I'll be needing 2 trucks of cocoa. So that analysis of trucks is the variable cost. So it will change in respect to the amount produced. So the next one is total cost. Total cost is the sum of fixed cost and variable cost. And next one is marginal cost. It is the additional cost of one additional input. So let's take, for instance, I've already produced 200 sachets of Bonfita. Then after sharing, I noticed that the 200 the 200 was not enough. So it is important for me to go back and do as many as possible in order for others to get. So what if I'm producing later, what I'm adding to the initial 200 is what we call the marginal. So mathematically is given as MC equals to change in total cost over change in output. So let's look at example. Sorry. So let's look at example 1. The question is copy and complete the table. So we have this table. So based on what I explained before now, can someone tell me the value of, or sorry, what those values that will be in the column of fixed cost?
The total
$10.
cost.
No, for fixed cost,
$10.
The
$10.
fixed cost will be $10
So sweet. So $10, no change, nothing is going to change. Why?
because it's fixed.
Very correct. So we have $10 or true. What of for total cost?
Total cost for the first row will be $10.
That will be FC plus BC.
FC plus VC.
Okay, what are the resulting outputs?
10, 20, 37, 35, 50, 70, 120.
Okay, very correct. So we have the total cost to be 110, 20, 27, 35, 50, 70, 120. So the next one is marginal cost. Can anyone tell me for the first output, which is 0, since we don't have any output for the first row, it means the marginal cost to be 0. Now, what is the marginal cost for the second row? Can anybody?
For the second row, it will be $1.
$1? So sure. What's the
10,
formula?
10.
It's going to be
10
10.
minus 0 over
$10.
1 minus 0.
10 minus 0 over 1 minus 0. I think that's very correct. For the third row,
7.
7. For the fourth row,
7.
for the fourth row,
8.
Okay, I think you have. We're on point. So have marginal cost to be 10, 7,
Like I said
8,
too.
15. Yeah, very correct. So you have 10, 7, 8, 15, 20, 50. So this is going to be the marginal cost output. As simple as this is, if you don't know it, it might be quite difficult. And I was told that we'll be having CBT exam. So the exam is going to be CBT, and these are the basic questions they can always ask when it comes to CBT.
I don't tell you CBT
Mr. So someone said the marginal is not clear. Can you come again for the person?
Okay, now for the marginal, this is the marginal. Okay, let me write something on the screen for better understanding. Okay, for marginal cost times MC equals to change in TC over change in output. Okay, so this is the marginal cost formula. So let's now look at how do we get 10 here, or how do you have 10 there? So how do you have 10 here? The total cost for the first stage is 10, right? And the one for the second stage is 20. So that will be 20 minus 10. That's the total cost. So that means marginal cost 1 will be equals to 20 minus 10 divided by, now let's go back to the output. Now for the output, for the first one we have it, to be 0. For the second one we have it to be 1. That will be 1 minus 0. And that will give us 10. So MC2. Now we are done with this 20 minus 10. So the next one we are picking is 27 minus 10, minus 20 rather. So 27 minus 20, that will be 27 minus 20. That's change in total cost. Divided by, now let's go to the output. 2 minus 1.
Okay.
So we'll be getting 7. For MC3, so we'll go to the next one. That's 35 minus 27 divided by 3 minus 2. So you do that to the end of the, I don't know if that's clear.
Very clear.
Yeah, can I go on?
Yes, sir. Yes, sir. Go on.
Hello?
Go on, sir. You are good.
Hello, can anyone hear me?
We can.
Yes, sir.
Yes,
We can hear you. Go on.
We are with you.
Okay, sweet.
Go on, sir.
Okay. Okay. So that's the basic concept of fixed cost, total cost, and marginal cost. So let's go on. So we will now be looking at cost per unit. The cost per unit is what gives rise to your ABC, your ATC, and your AFC. That's average variable cost, average total cost, and average fixed cost. So the average variable cost is given as variable cost over quantity. Average fixed cost is given as fixed cost over quantity, and average total cost is given as total cost over quantity. Over total cost over quantity. Okay. So please note that at maximum output, total revenue is equals to total cost. And what is total revenue? Let's say, for instance, I made a product with the hope that I want to sell it. So the cost of making the product, let's assume that the cost of making the product is 1 million naira. Then after selling, so in my mind, I want to sell it 1.1 million naira, which means I'll be making a gain of 100,000 naira. So if I'm to find the total difference, it means I'll be having 1 million, the 1.1 million naira minus 1 million naira. That means the 1.1 million minus 1, that will give us 100,000 naira. That point is the maximum profit. But the question mark is, how do I know the amount of quantity I'm expected to sell in order for me to get my total revenue back? Let me come again. Total revenue is after selling those things I'm going to get back. Total cost is what I'll be expending from my hand. Okay. I made a product of so cost. So if I'm selling, how much am I selling in order for me to get my maximum, in order for me to be at maximum output? That means in order for me to get my maximum profit. Because the aim of every businessman is to make profit. So if I'm spending 1 million naira on the project, for me, I should not be getting nothing less than 2 million naira back. So that means you're saving me 3 million. So at what point, or how many quantity am I going to produce for me to have an output of 3 million naira? So at maximum output, total revenue is equal to total cost. So and that goes for your differential too. Let's take, for instance, your total revenue is given in terms of quantity, and your total cost is also given in terms of quantity. So you differentiate your total revenue with respect to quantity and your total cost with respect to quantity and you equate both. So you equate both to get Q, where Q is the quantity. Don't worry, we are going to solve question on that too. The second one the second aspect you need to note is that at maximum profit, total revenue minus total costs will produce the profit. Because if I did something for 1 million naira and I'm selling for 3 million naira, so the 3 million naira is the total revenue, the 1 million naira is the total cost. So the absolute difference gives me the profit. Okay, let's go on. Example 2, really? So example 2 is that we should compute the following table. So we asked to find the average total cost for 6 units, average fixed cost for 2 units, average variable cost for 4 units, average total cost for 1 unit, average fixed cost for 5 units, and average variable cost for 5 units, and average total cost for 5 units. So can I know, number one, anybody, what's the average total cost for 6 units?
20.
20. Can you explain how it is 20?
120 divided by 6.
Eh? Yeah, I can't hear you.
120 divided by 6.
120 divided by 6, that's 20. Very correct. Can anybody help with average fixed cost of 2 units?
10. Sorry,
Anybody?
5.
5.
5.
Hello?
You said 5. 5.
Average fixed cost of 2 units. Anybody?
Someone said
5.
5.
Eh?
5.
5.
I can't hear you. Hello?
Maru, 5. 5.
Okay, 5. So I think 5. I'm coming. Let me check the chat box. Yeah, 5 is very correct. 5 is very correct. So can someone tell me the average total cost for 5 units? Anybody?
14.
The average
14.
total cost for 5 units is what?
14.
Eh?
14.
Okay, 14. Yeah, that's very correct. 14. So solution. Okay, that's very correct. 14. So we can look at the table to get other values. So we can deduce from the table that the average total cost is equal to average variable cost plus average fixed cost. So let's look at it. For average variable cost and average fixed cost for the second column, we have 10 plus 10, that's 20. Average variable cost for the second row and average fixed cost of the third row rather is 8.50 plus 5, and that's 13.5. So if you do that to the last line, you should get ABC plus AFC equals to ATC. So can we go on? Can we go on?
Yes, sir, you can go on.
Okay. So example 3. Now this example 3 is picked from past question. So the question is given that TR equals to 600Q minus 3Q squared, then TC equals to 1000 plus 100Q plus 2Q squared. You are required to find the profit maximizing output. You're also required to find the maximum profit. Remember, I've already indicated some constraint that for you to have maximum output, the differential of your total revenue with respect to Q quantity is equal to the differential of your total cost with respect to quantity. Okay? So at maximum output, the TR, the Q equals to the TC over the Q. So if I'm to differentiate TR, I'll be having 600 minus 6Q, right?
Yes.
And if I'm to differentiate TC with respect to Q, I'll be having 100 plus 4Q. So if I'm equating both to make it, to get the value of Q, at the end I'll be getting 50 units. So this 50 units is the output, is the maximum output. That means the maximum quantity that will be produced for you to attain maximum output, for both to be equal. For the second one, we are expected to find maximum profit. And we already declared that maximum profit is TR minus TC. So the Q you are getting from the first maximum output, substitute it back into the TR and the TC. Then you'll be getting a resulting value of 11,500. So you'll be getting a resulting output of 11,500. Okay. Any question? Can I go on?
Go on, please.
So the last aspect to be looking at in today's class, or the general revision, is the break-even analysis. Every single topic I've been doing, they're actually in our syllabus because I used the syllabus to prepare the slide. So every single topic, you can find it in the syllabus. So as an engineer, you need to master the use of break-even analysis. We also use break-even analysis to know when our revenue will be equal to our costs. Okay, I'll be defining this break-even in two formats. I'll be using the business definition, and I'll also be using the engineering definition. Now, for the business definition, it is a point which revenue of product cover the cost associated with production. Like I said, let's say, for instance, I produce a cup for 10 naira. I produce a cup for 10 naira. Also, the cost of producing cups is about 200,000 naira. So how many quantity am I going to sell for 50 naira in order to get what? In order to get an amount equal or greater to the initial starting cost. Let me come again. The cost of manufacturing a cup is 200,000 naira. And the plan is that after producing a cup for 200,000 naira, I will be selling each cup for 50 naira. So break-even analysis will help you know that, will help you know the amount of cup you need to sell at 15 naira for you to attain a value equal or greater than the what? Or greater than the cost price or the manufacturing price. So in engineering, it is used to compare two alternatives and defines the point at which the alternatives are equivalent. Let's take, for instance, if I want to erect a building, then I consulted to civil engineering firm. If Mr. A is giving me quantity, a bill of 20 quantities, and Mr. B is giving me a bill of 50 quantities. So what I need to look at is, okay, if Mr. A is giving me 20, Mr. B is giving me 50. What are the things Mr. A is adding that Mr. B is not adding? Or what are the things Mr. B has equally overlooked that Mr. A is not doing so? So we'll look at the analysis together. We'll compare all output, we compare all inputs. Then we come to conclusion by having an equivalent structure. So at that point, you can decide to give both companies to work on the project because you've been able to establish a break-even analysis before the start of the project. So break even could be single product going to market or separate investment. Now, single product was the cup I made as an example. Separate investment was the building I made as an example. So what are the steps you need to follow before you undergo break even? Number one, you need to know the type of break even, and you also need to analyze relevant scope. Okay, that's done. So what are the conditions for simplification? If it is a single product, you will compare the equivalent uniform annual benefit to equivalent annual cost. Remember, the chart I gave you the other time. Now you are dealing with annual. So by virtue of design, if you are giving present, then you convert your present to annual using the chart. So that will be A slash P, I, what, N. Then you get your annual value. But yeah, we most times you'll be giving those values in annual. So you don't really have to go through the stress by converting to annual, do this, do that. So if it is a single product, you will need to compare the equivalent uniform annual benefits to the equivalent uniform annual cost. But if it is separate investment, you will need to compare their individual equivalent uniform annual benefit, or you also compare their individual equivalent uniform annual cost. What am I saying? Let's say, for instance, I'm considering investment A, investment B. For investment A, is going to have EUAB, that means the annual uniform annual benefit. For investment B, it's still going to have EUAB, that means equivalent uniform annual benefit. It's going to have both of them, they will equally have their EUAB. So I compare them. If I'm not comparing their EUAB, then I would definitely be comparing their EUAC. You can see that it is stylishly different from single product. In single product, I compare, you see the same value I'm dealing with, you see the same component I'm dealing with for single product. So I'm comparing the equivalent uniform annual benefit to its equivalent uniform annual cost. But if it is separate investment, what am I going to do? For the first investment, I get I calculate for its equivalent uniform annual benefit. For the second one too, I calculate for its equivalent uniform annual benefit. Then I compare them. Similar thing goes for their equivalent uniform annual cost. You can also compare them. Okay, so let's go on. So let's take an example. A firm is in the process of deciding whether or not they should move forward with producing an auto part. If the operation cost of producing the part is 500,000 naira annually, material cost of producing each part will be 67 naira per unit. If the company sells the part at an average price of 125 naira, how many units must be sold each year to break even? How many units must be sold each year to break even? So that means to break even means to get a value, to get a benefit value equals to the cost value. That's not break even. To get a benefit value equals to what? Equals to the cost value. So that you don't want to incur any loss. So because that's the aim as as a businessman, you just have to work within that scope. So you will not incur any loss. When you are making too much of losses in business, then you need to checkmate the business again. Okay. Remember the first constraint we said, number one is identify the type. Now it is obvious that this is just a single product because the company is producing a part and they are selling the part. So it is a single product. So therefore, we will be comparing the annual cost to its what? To its annual benefits. So let's now look at the annual cost and the annual benefits. Now the parameters we can get from the questions are, from the question rather, are the annual operating cost, which is 500,000 naira, the manufacturing cost, which is 67 naira, and the projected selling price, which is 125, and y should be the number of units. So the number of units will allow us to get the break-even point. Remember, what is break-even? You are comparing the annual cost to its benefit, its annual benefit. So to get the value of Y. Okay, good. For us to get the cost, it means we'll be adding the annual operating cost and the manufacturing cost. So, but how do you now get the manufacturing cost? If the company is to produce 200, so you are multiplying 200 by a unit price. So that will give you the total manufacturing price of the part. Then you add the total manufacturing price, so the total manufacturing cost to the annual operating cost to get your equivalent uniform annual cost or total cost. Why we have, since if the company will be selling it at the rate of 225 naira, it means they'll be getting a benefit of 125 naira. But how many are they expected to sell for them to be able to have an amount equals to their annual cost, to their total annual cost? And this is the equation. So you have 500,000 plus 67 times Y. This 67 times Y is the total manufacturing cost, equals to 125 times Y, where this 125 times Y is the cost. So it is the total benefit that must be received before I can have an intersecting value of the total annual cost. So if you solve this mathematically, you have Y to be equals to 8,621 units. I hope I'm communicating. Hello?
Yes, sir, you can go.
We
Yes,
see,
yes,
sir.
yeah.
We can hear you, sir.
Can hear you.
Okay, so that's the last aspect of the course. Thank you for listening. I wish everyone success in I wish everyone success in tomorrow's exam. Thank you
Thank you,
very
sir.
much.
Amen,
We
sir.
Thank you
Thank
very
you
much,
so
sir.
much, Mr. Yusuf. We are really, really grateful. Just a quick note, the YouTube link will be shared very soon in the next 1 hour latest, and also the slide will be shared to every group chat, so you can just access it from your group chat. Thank you so much, guys, for coming. God bless. Bye.
Okay.
Yeah, bye-bye, everyone.